So the title of the session is Application Modernization and Rabbits, and I'm going to show you or explain in a minute why I chose the title. Again, my name is Niklas Heitloff. I work as a developer advocate at IBM, and I love working as a developer advocate because I can learn new technologies every day. And the best way for me to learn new technologies is to actually try them and to develop something myself. And that's exactly what I've done in order to learn the topic application modernization. So I've built this one sample that I'm going to use throughout the session so that every one of you can run all of the demos yourself right after the session. It's available as open source, and I'm going to show the link at the end of this presentation. So let's need to activate my screen here. Okay, so now, why did I choose the title Application Modernization and Rabbits? And in order to do that, to explain that, let me show you a really quick 2 minutes video that explains it.
Hi, I'm Niklas, an IBM developer advocate and part-time bunny keeper. Today, I'm going to explain the benefits of app modernization using rabbits. I got my kids 2 rabbits this spring. We put them in a simple cage and everything was just fine until we had a bunny explosion. A simple cage is like your monolithic app. It may be working fine until you have an explosion of requests and then you need to modernize. This was a catalyst for us to modernize the cage and replace it with a structure of several hutches and pathways. Let's look at this structure as a microservices application. These hutches are connected with pathways, just like loosely coupled microservices. My end users are having a much better and faster experience with this modernized structure. When I need to repair one of these hutches, the rabbits can continue moving around, and similarly for a microservices application. If you need to fix or extend one of your microservices, you can replace it while your application continues to run. In other words, you are more agile compared to monolithic architectures. The other benefit of app modernization is efficiency. All kids can feed the rabbits at the same time, which means we are done faster. And now I need to make sure that my end users are cleaning the hutches.
Okay, so that was the video. Now, there was a lot of information in this video. Let me recap quickly the main reasons why you should consider modernizing your applications. Number 1, more agility. Number 2, better user experiences. And number 3, reduced costs. In this session today, I will focus on the first reason, more agility. In other words, the ability to faster deliver new functionality and the ability to innovate. So there are, as I said in the video, there are a number of advantages that microservices-based architectures give you. The advantage that I highlighted in the video was resiliency. When you break down a monolith into separate microservices, the application cannot crash as a whole. You can update separate microservices independently from each other, and that's certainly one of the huge advantages of microservices compared with classic monolithic architectures. There are a number of reasons or a number of strategies how you can modernize your applications or how you can deal with legacy applications. Number 1, simply retire applications. And this might sound obvious or stupid, but in reality, what we have seen is that there's a big number of applications that is not used and people are just too scared to shut or to remove these applications. Number 2 is don't touch the applications. And again, that might sound stupid, but it's also a valid strategy, especially if you don't have the skills anymore that really allow you to make changes to the application. Number 3, lift and shift. This is certainly the easiest way to move existing workloads into the cloud. However, at the same time, it gives you some advantages, but not the full benefits of cloud-native applications. The good news about lift and shift is, and the reason why many people do that, is because you don't have to change your code. The 2 most exciting strategies, though, are 4, containerize, and 5, refactor. And these two strategies is what I'm going to explain in this talk. As I said, I built my own sample application, and well, I didn't build the original version. The original version was 10 years old, which you see here on the left-hand side. It comes with a web interface built with the Dojo toolkit, which was popular at that time. And on the right-hand side, there is a new modernized version of this application. Again, let's take a quick look how these work, how these applications work. Okay, so this is the Dojo-based version, and I should say it's an e-commerce application, a really simple one. There isn't a whole lot of functionality in it, but that's on purpose because I want to really focus here on the technology rather than complicated business use cases. So what you can do as an end user of this application is you can go to the shop or to the catalog. You can navigate through the different categories. You can choose one of the products, and then back then, 10 years ago, you would use a drag and drop to drag something into your shopping cart. The shopping cart is displayed here in the right column, and there's also this order history tab. This is the new application. It's very similar in terms of functionality, right? You have the catalog again, or the navigator with the catalog on the left-hand side. You can switch between the different categories. And again, you can pick one of these items and add them to the shopping cart. And then the number of items in the shopping cart is updated in the navigator. And you can also go into the shopping cart to see the list of all items that you ordered. Now, this is the result of this modernized application, which I'm going to explain in this talk. As you can see, I'm not only having here one application or one container, I actually have, I don't know, 10, more than 10, 14, I think, different containers, and I explain most of them in this presentation. So let's go back to the slides right here. Now, before I really get started to explain how exactly I've done that, I want to make sure you understand that application modernization is a journey. It doesn't happen overnight. There is no magic, and it doesn't happen automatically. You have to really understand what you do. And my advice is take baby steps. Don't try to boil the ocean. Don't try to do too much in one step. Modernize step by step. Evaluate the value add and whether it was worth doing that step, and then continue. And the reason why I suggest that is because there's less risk that you break something. And again, you can see the actual value directly after every step. So in my sample application, I actually used 8 different steps. And this is too much to cover in only 30, 40 minutes today, but you can go to the repo to learn more. Essentially, what I did was to use a 10-year-old application, or maybe 12 years, I don't even know anymore. It was built with Java EE6, and it was run on Websphere traditional 8.5 running in a virtual machine. Then I moved the application over into a container, which gave me operational modernization or capabilities. In the next step, number 3, I actually updated from Websphere traditional to a more modern Java application runtime, which is Websphere Liberty. Step 4, I separated the front end from the back end so that I could easier change the UI or the web application in a later step. Step number 5, I changed from Websphere Liberty to Open Liberty. Open Liberty is the open source version of Websphere Liberty. It's basically the upstream project. Number 6 and 7, I used the Strangler Pattern, which I will explain, to really separate a certain piece of functionality, the catalog, from the monolith to be able to scale independently. And in the last step, I actually used micro front ends for the UI. And again, I'm going to explain why I've done that at the end of this talk. So let's take a look at the very beginning here, the starting point. This is kind of the high-level architecture. There are only 2 virtual machines. One is running the database, in this case DB2. The other one is running the Websphere traditional server, and both the monolith UI and the monolith backend is really one application. So now, in the first step, I had to move the workload, the application, from a virtual machine into a container. And again, that allows me to benefit from operational advantages. For example, if all you have is a Kubernetes cluster or OpenShift, you can manage all of your workloads consistently. You can use the same monitoring, the same logging. You don't need any specific skills, any proprietary skills, and that allows you to manage and organize your applications much easier, even though you don't really benefit from cloud native capabilities like health checks or any advanced microservices technologies. In order to do that, I've used a tool that IBM provides. It's called the IBM Cloud Transformation Advisor. You can run this tool locally. It's just a Docker container, and it collects the data, and as a result, it tells you what you need to change. Again, in this step, I want to move my application from a VM into a container. So application transformation advisor shows you the places in the code that you need to change. And I'm going to talk a little bit more about that in a minute. And most importantly, it also generates these property files or these configuration files. Most important one is obviously the Docker file, right? So it tells you this is a Docker file and this is how you move from a VM into a container. And also there's a server XML, which is the configuration of Websphere applications, Websphere application servers. And POM XML obviously is what is used with Maven for dependency management. So all of these are provided for you, which makes this migration step or modernization step very easy. Now, I said you need, in some cases, also to change code. And we have another really great tool, which is called the IBM Websphere Application Migration Toolkit. It's an extension to Eclipse, and it allows you to see all the places in the code that you need to change directly in your code. And here's how it looks like. In the first step, you define the configuration. So what I do here is to say, I want to modernize from a Websphere application server traditional 8.5 to Liberty. I want to switch from Java EE 6 to 8. I want to switch from Java 6 to 8, etc. And then as a result, you get this. You get two Eclipse views. One is here at the bottom. That one shows you all the places in the code where you might have to do changes. And the Eclipse view in the right column shows you basically the help. It tells you what and how to change things. In the easiest case, there's even sometimes a quick fix capability, which makes it even easier to change code. Okay, so I skipped a couple of details now, but essentially I've now moved from Websphere traditional, from Java EE 6 to Websphere Liberty. Now in the next step, I switched or I separated the UIs, and this is kind of what you see here. So now we have a data layer, a backend layer, and a front-end layer, basically a typical 3 tiers architecture if you want. And in order to communicate between the front-end and back-end, REST APIs are used. However, these are not RESTful APIs. Some people think that, or want everything that has to do with RESTful. In this case, I've used another pattern. It's called backend for frontend. So they are REST APIs, but these APIs are not really focused on resources, but they are really business oriented, and they give more optimized API, or they provide more optimized APIs for the front end. So there's a communication, between the UI and the backend using REST, but again, not RESTful. So now in the next step, I want to upgrade from Websphere Liberty to OpenLiberty. Again, OpenLiberty is the open source version of Websphere Liberty. Websphere Liberty is IBM's commercial offering. One reason why I wanted to do that is because I'm a big fan of open source. Whenever possible, I want to use open source. That's one reason. Another reason, which might be even more important, is that I've heard, I'm not a salesperson, I'm a technical person, but I've also heard you can save some license costs. And maybe the most important point is that OpenLiberty has a great community. And as a developer, I want to be able to go to Stack Overflow or to the OpenLiberty website, and I want to get help. And this is certainly possible. There's a really big and successful community around OpenLiberty because it's based on open source that allows you to get support in many cases much quicker than any other option. So before I move on, let me be very clear. I think there are different options when you want to migrate or modernize an old, a 10-year-old Java application. There are certainly many options for the target runtime. It could be a Jakarta EE server, it could be Quarkus, it could be Spring, it could be other Java frameworks. My recommendation is, if you want to modernize a Java EE application, The best target is certainly a modern Jakarta EE application runtime. And the reason is because Jakarta or Java EE supports upwards compatibility, at least in many cases, maybe not all. I've seen some issues, but in general, it's much easier to update from Java EE to Jakarta EE. So that's the big advantage. And that's the reason why I've used OpenLiberty here as my target runtime. Okay, so in the next step, though, I want to show how to actually use microservices. So far, I haven't used microservices. I haven't really used cloud native. All I did was to move an existing monolith into a container and modernize the application runtime. I haven't really done any big code changes. I haven't really done any refactoring. And there's benefits, as I explained earlier in the video. However, at the same time, I want to make clear you understand that monoliths don't have to be evil. They are not always evil. There are good reasons why you might want to stick with monoliths. And a good example is certainly transactions. I think, it's much easier to do transactions that spawn multiple components in one monolith. It's also possible in microservices, but I think it's a lot more complicated in many cases, not worth it. Another reason why you might want to stick with monoliths is like if you only have, let's say, I don't know, 100 or a couple of 100 lines of code, it might not make really sense to split these two different things, because it's much easier to have everything in one place. But again, mileage may vary for you. But now let's move on and let's talk about microservices. Now, one good way to do that, to start using microservices, is using the Strangler pattern. The Strangler pattern can be used to identify the first microservice or the first microservices that you want to split from your existing monolith and run independently from the monolith. And I really like this pattern because it allows you to do changes in stages. This goes back to what I said earlier, take baby steps. Don't try to do too many things at the same time. And the Strangler pattern is a really good way to just, identify the first microservices, the first microservice that could be independent from the monolith, so that, for example, you can scale these services and these applications separately from each other. In my case, in my example, this makes a lot of sense because the catalog is primarily used by users, or most users use the catalog only. Let's put it this way. Most users only browse through the catalog, and only few users actually start the order process. So it makes a lot of sense to be able to scale the catalog service independently from the rest of the application. And this pattern is actually something that I didn't invent. It has been around for a long time. And as often, Martin Fowler was the first one who wrote about it. Now, in order to identify the first microservice that you want to separate or split from your monolith, there are different approaches. One approach that I really like is yet another tool that IBM provides. It's called Mono2Micro. The way this tool works is that you point it to your existing source code, the source code of the monolith, and it reads all the classes and methods and dependencies and so forth. But also it evaluates the invocation hierarchies or chains of method calls at runtime. So the way you do that is you define use cases, so the typical things end users would do, and that is measured as well. And Mono2Micro basically creates a proposal for you or recommendation how you want to split your application into multiple parts. So what you see here, and let's ignore everything on the left-hand side. Let's ignore everything here in red and blue. Let's just focus on the red, the purple and the green circles here. Everything in green is basically the remaining monolith, right? Ordering and so forth, histories. And everything in purple is the catalog. So basically, Mono2Micro basically confirmed what I told you earlier. And this is exactly what I wanted, right? So it's a really great tool that helps you to identify the first microservice that you might want to split from the monolith. Now, the important thing here is that you need to minimize the dependencies between these different rectangles. And I should say one more thing. The reason why these rectangles are called partition 0 and partition 2 is because Mono2Micro uses AI internally. And these are terms that data scientists, etc., use. Now, as a developer, you might expect rather something like microservice 1, microservice 2 or something. But that aside, the result is pretty good. Now, again, back to what I started to say, or started to explain, the dependencies between these rectangles, they have to be minimized. So in this case, it's actually rather good. There's only 2 lines between the purple and the green circles. And that's good because you don't want to create microservices for the purpose of creating microservices. What you really want is to decouple certain components within your application. And that is achieved by having as little dependencies as possible. Because what you really don't want to do is to build distributed monoliths. And this is something that I've seen a lot. People have heard about microservices and they just want to try it and they start, breaking down a monolith in 5 microservices. But all they really have at the end of the day is often distributed monoliths where microservices have dependencies and invoke REST APIs between each other in a synchronous way, in a blocking way. And this is certainly an anti-pattern, something you really need to avoid. Now, I think the best reason to avoid that, or at least to mitigate that, is to use event-driven architectures. And this is something, again, that I've used in my example as well. So rather than invoking synchronous REST APIs, I use here Kafka as a messaging service in the backend. And let me show you, I think, actually I have, before I show the architecture slide, let me show you how this looks like in the UI. Okay, so this is the modernized version. And what I do here, one second. Oh, no, that was not it. One second. That's the right one, sorry. So that's a video. Okay, so this is the modernized UI. I can go into the shopping cart and the price is now $29.99, Return of the Jedi. And when I invoke here a REST API, a put call command to update the price to 50, and then I see the price change right here in the shopping cart. And this even works for the old UI. So there's also the new price 50. Now, what you just saw, let me go back to the slides. Okay, so what you just saw is a dependency between the catalog service, the microservice, and the remaining monolith, because really only the catalog service knows the current price. But in order to show the shopping cart, the remaining monolith needs to know this information. Rather than invoking the catalog service synchronous whenever this page is displayed, I use caching to store this information redundantly in the DB2 database. Again, the DB2 database is what is used by the remaining monolith. And what you can see here on the right-hand side is that I added a new column called price current. So I use a simple caching here in order to minimize the dependencies. And this is the resulting architecture. So again, we still have one monolith in the front end, but then we have the catalog service, the first microservice that we separated out. That one I implemented with Quarkus. The remaining monolith can still run on OpenLiberty or with Quarkus. I have actually 2 versions of that same service. The remaining monolith continues to use DB2. The new microservice, the new catalog microservice, uses Postgres, and they communicate asynchronously via messaging and Apache Kafka. So when you modernize applications, one of the questions I hear a lot is, what target application server or runtime should you use? And I started to talk a little bit about that. I said, if you want to modernize Java EE, then by default, you should look into Jakarta EE runtimes, right? That makes a lot of sense because of the upwards compatibility. One other thing you really should take into account is to pick a good JVM. And one JVM I want to highlight here is the one that IBM open sourced 2, maybe 3 years ago. It's called OpenJ9. It's available again as open source. And it's really efficient for container workloads because it was designed to run on really small handheld devices. So it consumes a lot less memory compared to other JVMs, almost half of the memory only, which is a lot of money, especially when we talk about cloud. Another thing you should have in mind is that in order to build new and modern applications, reactive technologies are becoming more and more popular. And as part of my sample, I've used reactive technologies to show how to even implement reactive REST endpoints and how to access data in the database reactively, or in other words, asynchronously. And that gives you huge efficiency benefits and gains. And this is something you really might want to look into. And that's actually the reason why I've used for my Quarkus implementation, for the catalog implementation, I've used Quarkus. And here are some examples. So I've implemented the same REST endpoint twice, both times using Quarkus. Once I implemented it reactively. This is what you see at the top. And once I implemented it as you would do it classically using imperative code or synchronous code. And I've invoked, in this example here, I've invoked the same REST API 30,000 times by simulating, I think, 100 or 300 users. And you can see the response time goes down from 1 minute 18 to 45 seconds. So this is a huge gain and a huge efficiency benefit. And this is one of the things why I really like Quarkus so much. I'm a big fan of Quarkus. Quarkus is a new, relatively new Java framework. I think it had recently the 2nd anniversary. There's lots of reasons why I love it. It's a lot of fun to work with it. There's good documentation. There's a lot of progress, a huge community. And it comes with a reactive engine. It comes with Eclipse Vertex built into Quarkus. So you can use this functionality out of the box without really having to include anything else. And again, this makes your applications much more efficient. Not certainly something for all modernization projects, but certainly something you should consider when you start implementing new microservices or when you start adding microservices to your existing monoliths. Okay, so now let's come to the last part of this talk. I've talked and explained how to basically use microservices in the backend. And again, many reasons why you want to do that. The main reason is you can update these microservices separately from each other. However, that only makes sense if you have the same architecture or the same design, not only in the backend, but also in the front end. And here's the use case. Let's say you want to add new functionality to your catalog service. Let's say you want to add ratings to your products, for example, number of stars. Then it's not good enough to just change the catalog backend microservice, but you also want to be able to change only that part of the UI separately from everything else. Because if you modelize your application in the backend and still have a monolithic front end, you don't really gain much. You really want to be able to modernize all of these things and update all of these things separately. And in the best case, to even have separate CI/CD pipelines to do these changes. And this is actually exactly what I've done. So this is the last architecture slide here. And as you can see, I separated or I split the one monolithic front end in 6 different so-called micro front ends. And here's another diagram that shows maybe better what I've done. So this is the new modernized UI. And I've used here Vue.js to implement these different visible these visible micro front ends. So I have the navigator, and then dependent on the selection of the navigator, I have the catalog, the order, and the account micro front end displayed in the right column. And there's actually 2 more non-UI components or non-visible components, the shell and the messaging component. Now, as I said, for the visible components, I chose Vue.js, but you could also use whatever you like, whether that's React or web components or vanilla JavaScript or Angular, whatever you like. And then the 2 non-visible components, the shell one, that one basically defines the layout and it makes sure to load all of these other micro front ends that you need. The second one, the messaging one, is a little bit more interesting. And this is basically the counterpart to Kafka in the backend. What I just talked about, the communication between the microservice and the remaining monolith, you want to have the same decoupling in the front end. And that's why I use RxJS, which are the some extensions, some reactive extensions for JavaScript. For example, you have objects like observables. And this is how I do communication between these different micro frontends. For example, if you browse through the catalog and you add an item to the order list or to the shopping cart, you need to communicate between the catalog micro frontend and the order micro frontend. And again, you don't want loose coupling, you don't want synchronous invocation calls, and that's exactly why I've used here RxJS. This is just a screenshot of how this application looks like from a developer point of view. So the framework that I've used is called Single Spar. Single Spar is a framework that allows you to pull all of these different micro frontends together in one place. And there are other alternatives. So Single Spar is not the only one, but they all work kind of similarly. They basically federate or aggregate all of these different micro frontends in the front end, in the browser. You can think of it, basically like in the backend when you use Node.js or JavaScript in the backend, you can say, export and import. And the same functionality is now with the modern browsers and also with polyfills, if necessary, also possible in web browsers. And this is what a developer would see. So right here, you can define exactly where to load which micro frontend from. In general, or by default, that would probably be all from a server, from a file storage or cloud storage, whatever, object storage. But then you can override different or separate specific micro front ends with local Node.js code, with local Vue.js code. So very powerful. And again, I don't have the time to go in more detail today, but all of this is documented and it's working in the repo. Okay, so let me do a quick time check. Okay, good. So this brings me almost to the end here of this talk. So we have a little bit of time for questions and answers. I recommend, if you want to learn more, check out the repo. It's in the IBM GitHub organization, and you can just search for application modernization, or you can type in the whole URL here, application modernization, Java EE Quarkus. I've written a series of blog entries about it. I think more than 20. There's videos, there's some samples and blogs and everything. So there should be a lot of documentation already available. We are also working on creating workshops so that you can run these things, in a step-by-step fashion. And I've also spent a lot of time to really make it easy to use this example. So what I've done here is to implement a whole lot of scripts to install and run the example. At this point, I'm using Docker Desktop. You need to make sure that you have enough disk space and CPUs and memory. But other than that, all you need to do, as you can see here, is one git clone and to invoke one single script. There's also more scripts to run and delete single services, etc. Very easy to use. What I'm working on right now is to extend this example to also deploy it easily to either Kubernetes or OpenShift. OpenShift is the enterprise distribution of Kubernetes. And I want to have some CI/CD pipelines using Tekton, Argo CD, etc., GitOps to really deploy this same example also very easily to different Kubernetes and OpenShift distributions. So I think that's everything that I had for today. Thanks a lot for your attention. And now we have some time for questions.